All right, hello everyone. Just making this quick video for our chassis team and the chassis jig capstone, just to help out with a quick and simple way to process tubes for tube notching. This video is also going to be publicly available, so if other teams are interested, this is a quick and easy way to go from a full SolidWorks weldments model of your chassis and be able to individually pick out tubes that have fairly complex joints, such as this one in the front here. Let me isolate this one here so we can take a closer look at that front joint. So you can see right here it meets up to both a square tube and a round tube, and it's a round tube itself. It's a kind of a hard joint to do, and of course you could have infinitely more complex joints than this, modeling five tube nodes and that kind of stuff. So we're going to be able to go from something like this to a flat pattern that we can then convert to a DXF to send to a CNC tube notcher and go through that workflow. Or we can also import that DXF into just a drawing, print it out on some sticker paper, stick it on the end of our tube, align two ends together, and we can just use an angle grinder and a die grinder to cut those notches out. So that's kind of what we're looking at. It'll be pretty straightforward. I'm only going to cover the part of actually flattening this tube. At that point, our chassis jig team should be good to go from there. They'll have documentation on how to use their tube notcher. And then, of course, printing out DXFs. I'll just show how to export those as well. So let's get right into it. Might as well just use that exact same tube. We're going to, actually that one has a pretty simple notch on the other side. Let's find something a little bit more wacky. Kind of like this tube here. It's got a fairly complex joint up at the top, and then it joins up to 2 or 3 tubes down at the bottom here. So to start off, first thing we need to do is insert this into a new part. It'll prompt me to create a new part itself, tell me which bodies I want to export. I will just click OK, import this into a new part, change the derived part units, and then it's going to ask me where I want to save this. Since I'm just doing this for a demonstration, I'm not going to save this, but we're making good use of our PDM here, and you can make an additional folder here for all of your individual tubes as they flatten out. It also helps to have a balloon drawing with all of your individual tubes labeled out, so you can say, hey, this is tube 21 flattened, and then you save that out into your subfolder. But like I said, this is just a demo, so I'm not going to save it, and we'll start running through the process. So now that everything's loaded in, we can create, so the first thing we need to do is, let's take a look at where our planes are. You can see that the planes are kind of out in space relative to the tube. It'd be very helpful for us to have this aligned with one of our primary axes, and then also to have it be pretty close to the origin. So what I'm going to do is I'm going to turn on the visibility of my origin. See, it's kind of way out over here. And then I'm going to create a reference axis from my from my top plane and from my right plane. I'm going to take both of those and I'm going to go to reference geometry and create a reference axis between 2 planes. Job's done. Then we're going to go to our direct editing tab, and if you don't have this tab activated, you can right click on any one of the tabs and it'll show you all of the different tab options there. So if you don't have, like, for example, data migration, I can turn on that tab. I don't need that tab, so I'm going to turn it back off. But you want to make sure your direct editing tab is active. Then we'll go to move and copy bodies. We're going to move this body. I'm going to use constraints to position it, and we're going to pick the outside face and then that axis, and that's going to make both of them concentric. Hit add, and we'll hit OK. So now it's aligned with that axis, but it's still kind of far away from the origin. You can use another move and copy bodies command, just in the translate and rotate section. We will move this along the Z axis a good bit closer to the origin. So maybe that far. Looks like around 700 millimeters. That's a little too far. 650. Cool. So we don't want it to be right on the origin. We'll talk about that a little bit later. just a little bit spaced out away from it. So 670, 660. Cool. There we go. Now our tube's pretty much aligned. We can get to flattening this out. So the best way that we found to flatten out these tubes is to use a surfacing workflow. And for that, I'm going to make sure your surfaces tab is active. I'm going to start by offsetting the outside surface by 0 millimeters. And you can see as I change from 10 millimeters to 0, this offset surface command is going to change from an offset to a copy. And it will still show up as a surface offset in your feature tree, but copy is exactly what it's doing. It's taking the outside surface and it's making a direct copy of it with all of its boundaries. And this is very helpful because as we go to our tube notcher, for example, our plasma cutter is going to be riding along the outside edge of the tube. So that's the one that we want to be cutting into the tube. However, when we look at places like this, where if we were to cut just this outside perimeter, we'd have extra material here. That's the thickness of the tube. That's not going to fit up very nicely. It's going to space out our tube from the other tube because there's extra material there. And the other thing is if we tried to weld to that little thin lip of tubing there, we wouldn't really get a good strong weld bond because we're not welding to the full thickness of the tube. We're just welding to this tiny little thin piece here. And if that thin piece breaks off from the main thickness of the tube, we'll have a bad time and we probably won't make it through, probably get black flagged out there. So what we want to do is take this inside perimeter here. We're going to cut it away from the outside edge of this tube. And the way we're going to do that is by doing a ruled surface. Again, back in our surfaces tab, we're going to do a ruled surface. And what this is going to do is it's going to allow us to create a couple of different surfaces here. The one we want is perpendicular. It's going to be perpendicular to our initial axis that we align to. And then we're going to pick out the edges that we want to make that perpendicular surface to. You can start to see that it gives us a preview. It's going to the inside right now. What we want is for it to go outside. And the distance doesn't really matter here as long as it intersects the outside edge of the tube. And what you can see if we go to, let's say, a right view here, you can see that it just cuts straight out. So what we'll be left with is, once we trim this away from the outside surface, we'll be left with the part of the tube that is the full thickness, the full wall thickness from, I think this is a 0.95, or this might be an 0.65 tube. So we'll be left with only the part of the tube, the profile of the tube on the outside that is actually the full thickness. So we'll do that here, and we should be able to do this other edge as well at the exact same time. And yep, there we go. Cool, so we'll hit OK. Now we have 3 surface bodies. We have the outside surface, and then one of each of these. What we need to do now is use our trim surface command. We're going to be doing a standard trim because we have a trim tool that we're using to cut away another surface. And so we'll use this one here. And then by selecting keep selections, what we can do is we can just select the part of the surface that we want to keep instead of having to go through and individually select all these little bits that are still straggling on here. So we'll click on that, hit our green check mark, and I'm going to hit enter to launch that tool again, except this time I'm going to be using the other command or the other surface here. I'm going to click the main body again. I'm going to click right click to get finished up with that command. And so now we're pretty much done. So if I just isolate this surface here, that's our body. That's not what I want. I just want the surface. Hide those, and then hide our solid bodies as well. So now we have just this surface here. This is what our end product pretty much is. We can also highlight that to show the parts that we cut off of the tube in those little straggling bits that are thinner than the thickness of the wall. Parts that we don't want to weld to, the parts that if we cut those, have a bad time with fit up. So now we have our profile that we actually want to cut. And from here, we need to flatten it out. What we're going to do for this is we're going to create a sketch on our top plane. And we're going to go right down to our origin. And we're going to create a little thin rectangle that's going to cut away just a little tiny bit of the tube profile itself. And it's going to be a thickness that's imperceptible to the tube notcher, and also, just realizing my face is poorly lit, it's going to be imperceptible to the tube notcher. It's also going to be imperceptible to the tube. It's basically going to be 0.01 millimeters, one of the smallest dimensions that we can do within SolidWorks. Something that's small enough that we can still get in there and mess around with it. But again, when we cut out our external profile of the tube, if it's off by 0.01 millimeters, I don't think that will affect anything. If you're in a different boat than that, let me know. Definitely happy to hear how you're getting 0.01 millimeter tolerances out of your tube notching, and if that's important to you. But that said, again, we created this rectangle. One of its corners, and we want to keep in mind which one of its corners is based on the origin itself. And so this tube here is, or this line here is aligned with our z-axis here, the axis that we created. And then we're cutting 0.1 millimeters to what is the left side on my screen right now. So we want to keep that in mind. We want to keep in mind where our origin is and where we're cutting. So here, I'm going to go to curves, split line. You can also search split line up here in the commands, and then drag it down. So if you just click drag it down, it'll show up there right next to it. I tend to use split line a lot, so I have it set up separately there. So it's going to automatically select my sketch just because I had it highlighted already, but if it didn't, you can just go down here, click on your sketch. In here, we're going to click on the face that we want to project the sketch onto. So again, we want to be the projection drop box, and then we only want this to go down into a single direction. Basically, if we don't have this checked, it's going to project it up and down from that plane. Just want it to go one direction, and it down works just fine. Again, remember, our origin is to the left side here on this line, and that's going to be important in our next step here. So we're going to make that split line. You can see now there's a tiny little face there. And what we want to do is delete that face. So that should be in your Surfaces tab, delete face. You want to make sure that the option is set to just delete and not delete and patch or delete and fill. We're just going to click on that face and right click to OK that, and now we're done. So now this left edge is the one that is aligned with our origin. It's also aligned with one of our, it's going to be coincident to one of our planes, and we can double check that by measuring from that plane to that edge. Nope, not the face. I'm going to use my filters to make it so I just select edges, and then I'm going to go from that to the right plane. Two selected items intersect, so that means that there's no distance between them. That's the one that as we flatten out our surface, we want to keep consistent. So up here in the surface flatten tool, we're going to flatten out this surface. I'm going to pick out a vertex that we're going to be keeping fixed. So if you think about it, we're going to put basically a clamp on that, and we're going to start to pull the other edge of the surface out until it's completely flat. So we're going to click on that guy, and you can see that it flattens out. For some reason, it decides to go completely the other way for the preview. But again, we're keeping that one fixed. That's going to end up over here. And you can also see that the mesh that we're getting from this is fairly coarse. So what I'm going to do here is I'm just going to hit accept on this, and we're going to right click and take a look at a deformation plot. So you can see that on the edges here, it's stretching and compressing by about 0.2%. Kind of see the scale on the right side there. It's very messy on this side as well. If we go back into this tool and we crank our mesh settings all the way to the max, click OK. It's going to take a little minute here, so make sure you're doing this on a fairly beefy computer. In this case, we actually have very, very good numbers. 0.008% stretch and 0.006% compression. On some of the other tubes I've done, I've seen these numbers go up to about 0.02, and that's about the end, kind of where it stops. But since this is perhaps a simpler tube, or the mesh was nicer with the cutouts on this tube, don't know exactly what it is, but this deformation plot looks really, really nice. And again, you can see that there's just that little bit of stretch, and scale is max to min. So overall, we have a very, very low level of deformation. You can also double check this by hiding that with the tab key and measuring from one edge to the other edge and verifying that this distance here, 79.78 millimeters, is close enough to the circumference of this tube. So this is a 1-inch tube. I can pull up a calculator real quick. 25.4 inches times pi is going to give us our circumference, 79.79, and what we have is 79.78. So again, 0.01, basically the thickness of that cut that we made, is what's missing from this tube section. So that being said, this is now a fairly accurate, or as accurate as we have been able to manage. Again, we're always looking for improvements as well as a team, but this is as accurate of a procedure that we can do to get this surface. And again, this can be exported out as a DXF. Export to DXF or DWG, and I can save that somewhere else. And it's going to take a minute to think about it. And the only thing I need to do now is, just that. Origin, x-axis is going to be that way. And the y-axis would be nice if I had a straight line, but I will do, guess it won't let me do that there. Anyways, this should give me, I don't have to input all of those, but in this case, about that. Save. And now we have our DXF. So all in all, this is a pretty straightforward process. It took me about 15 minutes to explain, but overall, this should be pretty easy. You should be able to crank out each of these tubes in about 2 to 3 minutes per tube. Again, keep a dimensioned or a balloon drawing nearby so you can keep track of which tube number is which. Save them all into a folder, and then from there you can either print them all out by creating drawings, and you can section those drawings out and have breaks in your drawings so you're not printing 3-foot long stickers. You could also send them to a CNC tube notcher. But that's all I have for you guys. Again, a fairly simple workflow. Feel free to use it. Let me know if you have any improvements to it. My information is going to be down in the description